Thanks for joining me this afternoon. My name is Harpreet Singh. I am the Technical Support Engineer at Solartron Metrology. Right, to start with the question, what is Modbus? We all talk Modbus all the time. We heard this word many a times, but what exactly is Modbus? Modbus, in simplest terms, is a language. It's a standard industrial communications protocol. It's a de facto standard. A de facto standard is a standard for any product that has been used by many customers over the years, and they accept that this is a product or a standard or an application that works, and it's widely accepted by most people in the industry and everywhere else. And Modbus is open source. That means any company or any individual can use this open source code to write applications, and they can make devices which run Modbus protocol. And Modbus is most widely used protocol in the world at this moment. So that was the definition of Modbus. But what is it used for? Well, let's give you an example. For example, you have a supplier who supplies your device which talks Modbus, which is exactly a language. Then you make another device which talks the same language. So Modbus allows devices from different manufacturers to talk to each other using the same platform. And if you look at this image, at the bottom you have the RS-485 physical layer. And sitting on top is the master-slave layer, which is your device. So you have the actual two-wire connection, which is used by your device, which is either a master or a slave. And then at the top, you have the application layer, which is the actual Modbus application. So let me give you some top-level details of Modbus protocol, Modbus RTU, which is the Remote Terminal Unit. So please remember, the readings are actually stored inside MODIM first, and the parameter map is used by the PC or a PLC to interrogate MODIM to get those readings back from it. So how do you install a MODIM network? First thing, you need a PC or a PLC. And then you need to connect the MODIM to the PLC via 9-pin socket, a PSIM. The reason you need PSIM is because PLC can't power up the MODIM. You need an external power supply, which is 5 volt DC, to power the MODIM. And also, if you're using lasers on your network, you will need a 24 volt DC PSIM. And then you can stack up to 150 probes onto your MODIM network, as you can see in this little animation on your screen. But if you need further details on Orbit network installation, because in this slide I'm just only looking at the MODIM installation and MODIM interfacing with PLC, but if you need further details on how to install an Orbit network, you can look that into our systems manual that is included in the Orbit 3 support pack for Windows. So once you have installed the Orbit and the MODIM network, you need to configure the network. And to configure the network, we supply you with a utility called Gateway Configurator Utility. And that allows a computer to talk to the MODIM and the probes to set it up to be able to use it with the PC or a PLC. But for that, to be able to talk to the PC, you need a special cable, which is the RS-485 to USB adapter cable. So the first thing you do is you install the Solartron drivers onto your PC, you get the utility running, then you connect the special cable to your PC, and then you can start using the utility to set up the Orbit and the MODIM network so that it can be used with the PLC later on. So in this slide, you can see how the utility is being used. So on the left-hand side of this image, you see the ID numbers of lots of orbit modules, and you can use the standard notify and ping commands to find the modules on the MODIM network. And these modules, they can be given different addresses, because as you remember, first module on orbit network is usually 0, but you can actually change the positions of the modules on the orbit network. On the left-hand side of the screen, you can configure the Modbus settings. When I say Modbus settings, remember MODIM is a Modbus slave. And because MODIM is a Modbus slave, and on Modbus network, MODIM itself will have a network address. Say if it's just one MODIM on single network, you have MODIM address 0, 1, 2, 3, depending on how many modems you have on the same network. And also, you can select how to take readings. You can choose to take readings from individual sensors, or you can choose to take readings from all the sensors at the same time, which I would say are synchronized readings. And also, you can set things like resolution, averaging. And the settings can be saved onto a PC, so you can use the same settings at a later stage. So once the MODIM is configured, you don't have to set it up again and again. You can save the settings and load them onto the system whenever you wish to. Right, I'm going to give you a bit more detail on data transfer with the MODIM and the Modbus protocol. It might be a bit too technical in terms of, especially for the sales guys, but I think it gives us a good understanding of what's going behind, how the data is transferred from the probes to the MODIM and to the PLC. So any Modbus device, especially the MODIM, has a register size of 16 bits. So it has lots of memory, and each memory chip has lots of registers, and each register is 16 bits in size, and we call it one word as well. And the reading from a sensor, say a reading of 2 millimeters, takes up to 2 registers or 32 bits of data or 2 words. So one sensor reading is equal to 32 bits. So when you are reading Modbus device, you're reading 2 registers for one sensor reading. And these readings could be asynchronous mode or synchronous mode. Asynchronous is when you're taking readings from individual sensors, but they're not synchronized. But you can use the synchronized mode to take readings from all the sensors at the same time. And how do you do that? You do that by configuring the MODIM using the setup program. So to take synchronized readings, you set the network read mode to trigger sync. And if you want to take readings from individual sensors, you set the network read mode to update on read. So that was a bit about how the data is transferred in terms of bits and words. And let's move to the next level about Modbus commands, because the PLC is sending a command to MODIM, and the MODIM is sending a command to the probes to get the readings back. But what do these commands look like? And I hope I'm not giving you too much technical detail, but it'll be just about enough for you to understand. So when PLC send a command to a Modbus device, in our case the MODIM, you send binary or hex data. We do not send ASCII data. We use the Modbus function codes, and these function codes allow us to recognize which register we need to read to, or which register we need to write to, if we need to read just a single register of multiple registers. So these function codes like 03, 04, 06 define which registers you need to read for a particular piece of information. And at the bottom, you have a command structure. So I won't try and explain fully this example, but I'll just look at the first part. The first part, O1, is actually the ID of your MODIM on the Modbus network. So that's your MODIM number 1. And O3 is actually your sensor reading from using the Modbus command, and then O2 is actually the location of the sensor, is the network address of the sensor. So the MODIM interface module, which is at position 1 in the Modbus network, it will use Modbus function code 3 to read multiple registers, because these registers hold my reading values, from a probe on orbit network, which is sitting at location 2. So it's, in simple words, it's pretty straightforward. And at the bottom, you actually have the things like checksum byte and all the information, detailed information, how the command looks like. Right. So that was some of the techie stuff. So I'll give you take you from there to some things that you need to remember in terms of making sure your customers make the right choices and they do the right things when they use MODIM in their network. And the first most important thing is make sure the slave and the master port settings are mapped. What do I mean by that is each port setting has a baud rate. You need to select stop bits and you need to select the parity type. So a PLC and a MODIM should have the same settings. If any of these settings are slightly different, there will be no communication between the two devices. So please make sure these two settings are the same with the master and slave devices. And I mentioned in the last slide that we supply a special cable to program the MODIM, to configure it using the utility that we supply. But that cable is only to be used to configure, to set up MODIM, but you cannot use that cable for communication with a serial software on a PC. For that, you will need a standard RS485 to USB converter, and you can buy that cable from any third-party supplier. And as you can see in this table, these cables have a slight difference in terms of pin configuration. So the MODIM cable that we supply can only be used to configure MODIM. Oh, this is important. Orbit 2 probes can't be used with MODIM. The Orbit 2 probes and the Orbit 3 probes have a different hardware, different firmware running, and Orbit 2 probes, because of the hardware differences, cannot support communication with the MODIM interface module. Right, in terms of literature, the datasheet is available on Solartron Metrology's website, and the link is given on this slide. The user manual and the MODIM parameters map, which is very important document, is important for the people who make applications using Modbus, for the software guys. They can install and download the parameter map from our website as well. And also, to make life easy, when you install the Orbit 3 support pack for Windows, we supply the datasheet, the user manual, and the parameters map. Everything is included in the actual support pack. So once the support pack is installed, and if you go to the programs menu on your PC, you can see the datasheet and the other documents.
Thank you for listening.